Hello everyone. So this is the third lecture of network analysis series. So in this lecture we will study about Ohm's law, then we will study about resistor, inductor and capacitors. Okay, their current equation, energy and everything. Ohm's law, basically you have studied it in 10th, 11th, 12th classes. So what is Ohm's law? The main point is in a linear bilateral element. So it is applicable in linear bilateral element only. The elements has to be linear, okay, and it has to be bilateral. The current should be allowed in both of the direction, okay. So the current flowing through a conductor is directly proportional to the voltage difference across it, okay. So the voltage difference across it is directly proportional to the current. So V is equals to IR, where R is a constant, okay. R is a constant that is known as a resistance. V is equals to IR is basically the Ohm's law. If we see from like surface level, अगर ऊपर ऊपर से देखें तो V equals to IR ये होता है. But reality, what is the reality? The reality is that this was not the real statement that Ohm's gave. Okay, this was not the actual law. The actual law was this. Like it will not be used anywhere. I'm just telling you for your knowledge. Okay, J equals to sigma I, where J is current density. Okay, ampere per meter square. Okay, here as well I need to write the unit, not unit but the sign is ohm, like this. Resistance, we will study about the resistance later on. Okay, so basically what is J? J is I by A. Okay, what is sigma? Let it be sigma. And what is V? V is L. V is V by L. Okay, the voltage difference across this length, V by capital L, we can write V by capital L. Okay, so from here what do you see? 1 upon sigma into L by A into I is equals to V. So basically V is equals to I R. From this expression we get this, and where R is, what is R? Where R is 1 upon sigma into L by A. Okay, sigma is the conductivity. Okay, that is, oh, forget about it. What is L? L is the length of the conductor. And what is A? Cross sectional area. Cross sectional area of the conductor. Okay, so this was the actual law, J equals to sigma I. From this we derive to V equals to IR. Okay, where R is 1 upon C. This is a constant quantity. For a given conductor, this is a constant quantity. Okay, so this is what Ohm's law is. Let's move on to studying about those elements. So here what did we just saw? V equals to IR. R is a constant element that we call as resistance. Now what is a resistor? Resistor basically opposes the flow of current. In any conductor, it opposes the flow of current. So higher the resistance, lesser the current. Okay, so let's just see this. Let's assume there is this I current is flowing here, and this is potential V is developed. So the current will always flow from flows from high potential to low potential in a resistor. Low potential in a resistor. Okay, in a resistor the current will always flow from high to low. If the current is flowing in this direction, I will write current is flowing in this direction, I will write this one as positive and the next one as negative. Okay, if the current was flowing in this direction, I would have written this one as positive and this one as negative. Okay, so the current is always flowing from high potential to low potential in an inductor, in a resistor. Okay, So R, we call it resistance. Okay, R is basically rho into L by A. What did we wrote here? 1 upon sigma into L by A or rho into L by A. So rho is known as resistivity, and that is equals to 1 upon sigma. L is the length of the conductor and A is the cross sectional area that we know. Okay, so basically this is rho, and for a given conductor, the resistance is constant. Okay, so that's all we can write about a resistor. R is equals to rho L by A. So this is what we can write about it. Okay, so let's move on to this question. You need to write down the value of V and I with sign. What did I say? Let's move on to the first question. This is given like this. Resistor R, the current is flowing in this direction, but the voltage given is like this. What did I say? The current will always flow from high potential to low potential. So actually it should have looked like this, right? So this should be V dash. So what I can write is that if I need to write V dash, what is V dash? V dash is equals to current is flowing from high to low potential. Talking about V dash, forget about V. Just talk about V dash. V dash is I into R, right? Current is flowing from high direction to low direction. Now this is first. What is V dash? V dash is equals to minus V, right? Positive is here, negative is here. So V dash is equals to minus V. So basically V is equals to minus IR. This is equation 1. So you don't need to take V dash or V every time. You just need to see if the current is flowing from high direction, high potential to low potential, then it is fine. If it is flowing from low to high, then there should be a negative sign. And the other thing you can write is I is equals to minus V by R. Okay. The current should always flow from high potential to low potential. Okay. These basic things are there, but many times people don't even put much focus on this and they get it wrong. Like most of you must be already knowing it, but let's assume a second semester guy who is studying it, or a first semester guy who didn't study well in his 11th or 12th standard, then it will be a problem for him. So we should start from very basic, from very zero we are starting. Okay, here the current is flowing from high potential to plus to minus, then it is fine. V equals to IR. Okay, and I is equals to V by R. Now moving on to this C part. This is R they have shown, and the direction is like this. The current is flowing in this direction, or I can make the current is flowing like this, right? So here also the current is flowing from low potential to high potential, from low to high in a resistor. In a resistor you need to see, not after the resistor. In a resistor you need to see, in a resistor. In the resistor the current is flowing from low to high. So it should be V should be equals to minus IR, right? So I would be equals to minus V by R. Okay. So basically what you can understand is that simply in a resistor, if I make it like this, in a resistor I have shown that there is some voltage. So what you can do, this can be replaced with the resistance R with the current flowing in this direction, that will be V by R. Did you understand it? If V by R is currently flowing in this direction, what will be the voltage drop across this resistor? V by R into R in this direction. V by R into R in this direction, that is V. Did you understand it? So if there is some circuit where you just see like this, what you will do? You will just get a current V by R in this direction, from upward to downward. In the resistor, the current will always flow from high potential to low potential. Okay. Or like there is some circuit given like this it is given, and let's take a value now. 5 volt and this is 5 ohm. 5 ohm. I actually forgot to write down the unit. Here I will write down unit of resistance. So unit of resistance is ohm. Ohm. Okay. This is 5 ohm there. So what it will be replaced with? Current will always flow from upward to downward. So what will be the value of current? V by R. Value of current will be V by R. So 5 by 5, 1 ampere. 1 ampere current is flowing from up to down. And this is 5 volt. 5 ohm. So 5 ohm current from flowing from up to down. If we need to make the voltage now, so how will you write? The current will flow from high to low, plus minus, high to low. What is the sign? What is the value? 5 volt. I into R, 5 volt. Like this. Did you understand it? I hope you have. Now what is conductance? V equals to IR, right? I can write I is equals to V by R, or I can write I is equals to GV. Okay, so basically what is conductance? Conductance, G is 1 by R. Okay, and the unit is mho. Unit is mho. Okay, or sometimes they call it Siemens. Okay, Siemens they call it sometimes. S by S they also write. So if somewhere it is written as 3S, what does that mean? It is 1 by 3 ohm. Okay, let's write it by example. Example, if it is written as 3S, what does that mean? It means 1 by 3 ohm. Okay, 3S conductance, what does that mean? 1 by 3 ohm resistance. Okay, so sometimes you can see this term as well, like G. So you shouldn't be surprised like what is G. You should be knowing what is G. So this is basically about resistance. Just the direction of the current and the voltage, that is important. The current will always flow from higher potential to lower potential in a resistance. So you just need to always make the correct sign. Here the current is flowing from lower to high. That's why we made the sign to be negative. Here the current is flowing from low to high. In the resistor from low to high, then again the sign is negative. Here the current is flowing from high to low, then sign was positive only. Okay, did you understand it? And same in this manner, the current should flow from high to low. That's why we get a current of 1 ampere from high to low. Okay, now the capacitor. Okay, so there are two conducting plates. These are the two conducting plates. They are not like this, they are actually like this. Okay, there are two conducting plates, both of them are like this. These are the conducting plates. Okay, and this is a dielectric. Let's just call it a material. Okay, dielectric material. What is dielectric? You don't need to think about it. Okay, this is just a material. It can be air, it can be any material. Okay, so two plates, and then we apply a voltage source across it, a voltage across it. So what will happen? This positive charge will come up here, and this negative charge will come up here. Now since there is a gap in between, so this positive and negative charge cannot be neutralized. If there was no gap, both of the plates were like this. So positive charge would come here, negative charge would come here, both of would be neutralized. So now the charge cannot be neutralized. So a capacitor is a charge storing element. Capacitor is a charge storing element. Like in the previous analysis, like what is the difference between resistor and resistance? Resistor is an element and resistance is an property. Resistor element है और resistance property है. In the same way, capacitor is an element and capacitance is a property. Capacitor एक element है और capacitance एक property है. Okay, so capacitor is a charge storing element. So what we can write is that the charge that is accumulated charge, this is the charge accumulated, positive, and the same amount of negative. So accumulated charge Q is proportional to the applied voltage. Okay, V. So Q is proportional to V. So basically Q is equals to CV. Okay, so for a capacitor, this equation holds true. Q is equals to CV, where what is C? C is the capacitance. Okay, capacitor is a element while capacitance is a property. So C is a capacitance. And what is the expression of C? C is epsilon A by D. Okay, what is A? A is this area. Okay, this area is known as A. Okay, this is area A. And what is D? Distance between two plates. A is the cross sectional area and D is the distance between two plates. Okay, and this sign is known as epsilon. Okay, that is known as permittivity. But I am thinking, where should I write it? Epsilon. Epsilon, I will write it here. Okay, epsilon is the permittivity. Okay, this is known as permittivity. So this is the expression. You don't need to mug it up, just remember it. C is equals to epsilon A by D. But in the 11th 12th also you must have studied it. Okay, C is equals to epsilon A by D. Okay, okay. So now what we have seen is that Q is equals to CV. Okay, now we are writing the current equation, actually current voltage equation. Current voltage equation for capacitor. So Q is equals to C. What I do, I differentiate on both of the side. dq by dt. C will be constant now, because I just said that C is a constant, that is known as capacitance. So C is a constant quantity. Okay, so C will be outside and this will be dV by dt. What is dq by dt? That is the capacitor current, and that will be equals to dV by dt. Okay, so IC is the capacitor current. And what is V? V is the voltage across the capacitor. Okay, voltage across capacitor. Okay, so I is equals to C dV by dt, or C dVc by dt also they write sometimes, the voltage across the capacitor. So from here, if you need to, or we can write it like this, Vc only. Okay, Vc is the voltage across the capacitor. Okay, I will write it as Vc, and I can write it as Qc as well. The accumulated charge on capacitor. Okay, so also here also you will write at Qc. Okay, so IC is basically equals to C dVc by dt. And if you need to write the expression of Vc, how will you write it? Vc will be equals to 1 by C integration IC dot dt from minus infinity to some time t. Okay, Vc equals to 1 by C integration I dot, from here dt went here and then integrated on both sides. So Vc is equals to 1 by C integration I dot dt. Okay, so now basically Vc will become as 1 by C minus infinity to some time t naught. That time we don't know. Okay, plus 1 by C integration t naught to time t. Actually we had this window. Okay, so basically we had this window from minus infinity to t. We just took a time t naught. Okay, so we broke the integration in these two parts, from infinity to t naught, then t naught to t. Okay, so this can be written as Vc, the voltage across the capacitor till time t naught, plus 1 by t naught to t IC dt. Look, there is nothing difficult we did here. Okay, both the current and the capacitor and the voltage are the time dependent expression. Okay, so what did we just do? This expression we got, then we wrote it in the time domain, then we just saw that like till time t naught the capacitor is having one particular voltage, and after that it is also getting charged. Okay, like this is the capacitor, the capacitor till time t naught it is having, let's assume, 5 volt till time t naught, and then there is some current is flowing through it. So now if you if you want to write down the voltage across this capacitor V dash, how will you write? V dash will be equals to 5 plus 1 by C integration I naught into dt. So that's how you will write it. Did you understand it? The voltage across the capacitor will be initial voltage, that 5 till time t naught, then 1 by T integration I naught dt. Okay, understood? Good. Okay, you can write it down in your rough notebook or anything. Just to explain you, I told this. Okay, so this is all about the capacitor. Okay, capacitor. What is capacitor? The voltage across, the voltage is applied, the charge is accumulated. The charge is accumulated is Q equals to CV. C is the capacitance. C is equals to epsilon A d by epsilon A by D. Okay, don't need to mug it up or anything. You just remember it. Okay, then QC equals to C dV by dt. Just remember this. You have to remember. Always you have to remember. IC equals to C dV by dt, and then you can write down VC. VC is equals to 1 by C integration I dot dt. Then you can break it down in that way. Okay. So basically this is the final expression we get. Okay. So this is the current voltage equation of a capacitor. Then we will move to the current voltage equation for inductor. Before that, we study about the inductor completely. So basically, if a inductor is connected across a current source, then the voltage across the inductor will be L di by dt. Or before that, what we can do is that there is a term called flux linkage. Okay, so flux linkage and in an inductor is in inductor phi is proportional to the current flowing through inductor. So what is flux linkage? So whenever there is a current flowing through the inductor now, because of that current there will be some magnetic field across it. Okay, if the current is flowing, because of that, you must have studied some laws, Lenz law and everything. Because of that there will be some magnetic field around it. Okay, this is an inductor. If there is current flowing through it, there will be some magnetic field around it. So whatever the amount of magnetic field is linked with this inductor, that is known as flux linkage. Or whatever the amount of flux is linked with these inductors, that is known as flux linkage. Okay, we don't need to stress much upon that. Okay, this is a part of EMFT and this is a part of electrical machines as well. If you are from electrical background, you will have to study about it very deeply. If you are from EC background, no need to study about very deeply. You will study in electrical machines for electrical students. So basically the flux linkage, that is known as phi. So when there is a current, there will be some some magnetic field. So whatever the amount of magnetic field that is linked with this inductor is known as flux linkage, that you can think. Okay, so this is flux linkage. Okay, whatever the amount of magnetic field, I thought I said electric field, magnetic field. Okay, so whatever the amount of magnetic field that is linked with the inductor, that is known as flux linkage. Okay, so phi is equals to the current flowing through the inductor, so phi is equals to Li, where L is a constant and that is known as inductance. Okay, L is a constant and known as inductance. Okay, so basically phi is equals to Li. Now the EMF or the voltage across inductor, voltage across inductor, like in the previous analysis we got the expression of QC equals to C into VC, like Q equals to CV we got. So here we got phi equals to Li. So basically the voltage across the inductor is d phi by dt. Okay, VL I can write. Now your VL would be phi what is phi? It is Li by dt. L is a constant quantity, so VL would simply be L into di by dt. This is the expression of voltage across the inductor. Voltage across the inductor is the current flowing through it into L, the current flowing, the differentiation of the current flowing through it into the inductance. So VL is equals to L di by dt. Okay. Now the current equation. This is the voltage equation. Now the current equation. Current equation we will write. So VL is equals to L dIL by dt. We can write. Okay. IL is the current flowing through inductor. Okay. So IL would be 1 by L integration minus infinity to t VL into dt, or what else you can write. This can be an expression of time as well, right? Also the VL is an expression of time as well. We are not specifically mentioning it, but it can be. So minus infinity to time t naught VL into dt plus 1 by L from t naught to time t VL into dt. So this is IL till time t naught plus 1 by L. This is the same way that we are going, that we went in capacitor. Okay, the same way that we went in capacitor, it is acting as the same. So this is ILT. Okay, so what do you understand by this point? ILT, what is this? What do you understand by this point? Like this is an inductor and there is already some current flowing through it. It already has some current of 5 ampere. Now you need to write down the expression of current. So how you will write? So the current IL would be 5 ampere plus the voltage across it 1 by L voltage across it into dt and the integration. Okay, in the similar manner, right? In the similar manner, how did we write it here? 5 volt was always there, then 1 by t, the next expression from t naught to t and like that. Okay, so in the inductor part, it already has some current. 5 ampere current is already there. So how you will write the expression? 5 ampere current plus the further current that will be developed. Okay, very simple, very easy. Okay, fine. Also, one thing you need to know, like this is an inductor, and if the voltage is in this direction from high to low, so what will be the direction of current? This will be the direction of current. Okay, so this will be the direction of IL. Okay, this you need to know. And in case of capacitor, if this is the capacitor and this is the voltage across it, okay, forget about the voltage will come later on. This is the capacitor and the direction of current is this. So in what direction the voltage will be developed? In this direction. If the direction is this, then positive upward and negative downward. So in case of inductor and in case of capacitor, current will always flow from high to low potential. Okay, but in some case the current can flow from low to high potential as well while discharging. So this is the case of charging as well. What will be the case of discharging? That we will study in transient. We will completely study in transient. But just to give you a heads up, just to give you a basic idea, like this is the voltage. If the current is flowing in this direction, the capacitor is getting charged in this direction. The current is getting like this, so upward positive, lower negative. Okay. And in this case as well, if the current is getting into this direction, so upward will be positive, lower will be negative. Like in this way, the current is going like this, so this will be positive and this will be negative. Okay, so this is also a case of charging. What will be the case of discharging? That everything we will see in transient. All these things we will see in the transient analysis. Okay, just you need to have a basic idea before that. Okay, so everything we will be seeing in transient analysis. Okay, no worries about that. Okay, Now we will see the energy stored in a capacitor. So what is the energy stored? So again, this potential V is applied across the capacitor. So I is current flowing like this. So what is the energy? What is the expression of energy? I told you one thing. You just remember E equals to PT. E equals to PT. In the first lecture, we saw that E equals to PT. So integration minus infinity to infinity PT into dt. So that is the expression of energy across the capacitor. Okay. All this we will be studying in very deep. Okay. No need to worry about it. So what is PT? PT is Vt into It. What is electrical power? Electrical power is Vt into It. E minus infinity to infinity. Let Vt to be Vt. What is It? In case of capacitor, what is It? C dVc by dt. Right? In case of capacitor, IC is equals to C dVc by dt. Right? IC is equals to C dVc by dt. Right? So from here C will be common. Dt and dt will get cancelled. Dt and dt will get cancelled. Minus infinity to infinity. Vt into dVt. So the time limit is minus infinity to infinity. So the complete voltage that is across it. So the complete voltage that is across it is V only. So what we will get? Cv square by 2. What is the integration of x into dx? What is the integration of x into dx? That is x square by 2. Right? So the complete voltage basically, so in the same way, the integration of Vt into dV, that will be equals to V square by 2. V square T by 2. Okay, this can be confusing to some of the people. So let's write it down completely. It will be basically V square T by 2, right? Minus infinity to infinity. So what you can do? By 2 you can take here V square at infinity minus V square at minus infinity. Okay, C by 2. V square at infinity. What is the voltage finally? That is V. So V square. What is the voltage initially? When there was no voltage source connected, just a simple capacitor was there. So there was no voltage at that time. So that was 0. So basically it is Cv square by 2. Did you understand it? So this is the energy stored in a capacitor, that is equals to Cv square by 2. Okay, for this case, when the steady state voltage across the capacitor is V, so this is the energy stored in the capacitor, that is Cv square by 2. Did you understand it? Well and good. Okay, just the simple derivation. You don't need to mug up the derivation, just a very simple derivation it is. Anytime they ask you about the energy, you just need to apply this formula. Okay, Vt into It, C dV by dt, Cv square by 2. Okay, now the same way, try to calculate the energy in the inductor on your own. Try to calculate it on your own. Don't write the final expression and everything, or try to calculate on your own. So what you will do? E is equals to minus infinity to infinity. What is P? P will be, in case of it will be Vt into It into dt. So E minus infinity to infinity, It will remain as it is. What is Vt? It is L dit by dt into dt. Dt and dt will get cancelled. L will come outside. Minus infinity to infinity, It into dit. So what is that? What will we get finally? It will be Li square by 2. Basically, for an inductor, this is the energy stored in an inductor, that is Li square by 2, and energy stored in a capacitor is Cv square by 2. Okay, so did you understand it? So right now completely what we have studied, this is the summary. In a resistor, this was the Ohm's law. In a resistor, this is the voltage, the current will always flow from high to low. Okay, then for the inductor, for the capacitor we studied Q equals to Cv. Okay, the voltage developed is like this, and if the current is flowing in this direction, this is the charging case. Okay, so Vct is equals to Vct naught, initial voltage plus the further voltage that will be developed. Similarly, for inductor, initial current that was already there, plus the further current. Initial current that was already there, IL is equals to V. What did I do there? ILT. Okay. This is the wrong. This is wrong. Here I should have written IL. ILT. Initial current and the further current that is coming. Okay. This is the initial current. I note that is already there, and the further current. Okay. And the voltage developed will be this. Okay. And then the energy in capacitor RCV square, and energy in inductor, that is half Li square. Okay. So that's all we have studied till now. Okay. Just revise it once. Just see, you must be having the notes with you. Just revise it once. Okay. Everything is there. So that this is all we have studied now. Now we will study about the sources, voltage sources, current sources, independent voltage source, dependent voltage source, then these types. Okay.